Since humanity began exploring the universe and distant planets, the search for an Earth-like planet has become a shared aspiration for all humankind. In the hope of finding traces of extraterrestrial life, scientists have continuously explored space with great expectations and anticipation. And finally, in a miraculous breakthrough, two planets with Earth-like characteristics have been discovered very close to our solar system. These are two exoplanets that have been confirmed by the scientific community, one of which potentially possesses the necessary conditions for life. In other words, it lies within the habitable zone, also known as the Goldilocks zone. Two new exoplanets have been discovered, named LB8909b and LB8909c respectively, located relatively close to us at a distance of just 100 light-years. They both orbit a host star named LB8909. Based on findings from NASA's TESS, Transiting Exoplanet Surveys Satellite Space Telescope. Search for habitable planets eclipsing ultra-cool stars. Accordingly, astronomers have gathered initial, highly significant information about the two super-Earths as follows. The closest exoplanet to its host star, LB8909b, is about 30% larger than Earth and completes a full orbit around its dwarf star in a mere 2.7 Earth days. Its orbit passes the red dwarf star at a distance of only 2.8 million kilometers. According to scientists, this planet receives 4.1 times more heat and light from its central star than Earth does. The second exoplanet, named LB8909c, is slightly larger than LB8909b and about 40% larger than our Earth. Its orbit passes a point about 6 million kilometers from its host star. LB8909c completes one orbit approximately every 8.5 Earth days. Astronomers suggest that the second planet, named LB8909c, lies within its host star's habitable zone. A place with a moderate temperature, neither too hot nor too cold, so that water can exist in liquid form on the surface. According to astronomers, the illuminated hemisphere of the planet LB8909c receives approximately 90% of the heat and light from its host star that Earth receives from the Sun. This means that with a suitable atmosphere, liquid water could very well exist on the planet's surface. To verify this assumption in the future, astronomers expect to use NASA's Gamma-ray Space Observatory to study this system. If LB8909c has an atmosphere, the telescope will be able to detect its traces and simultaneously attempt to determine the chemical composition that makes up that atmosphere. Not long ago, the TESS telescope was also credited with discovering two new super-Earths. First is the super-Earth named TOI 1452b, located in the Draco constellation, 100 light-years from our planet. Scientists initially identified TOI 1452b as a potential ocean world, vast and expansive. Next is the super-Earth TOI 836b, located 90 light-years from our Earth. Although it possesses the characteristics of a super-Earth, TOI 836b is an extremely hot planet, with surface temperatures that can reach up to 500 degrees Celsius. According to Dr. Laetitia Delrez, an exoplanet researcher at the University of Liège, Belgium, and the lead author of the paper detailing this discovery, the TESS Space Telescope searches for exoplanets outside the solar system using the transit method. By simultaneously monitoring the brightness of thousands of stars, it searches for even the slightest dips in light, which could be a sign that a planet is passing in front of its host star. TESS's work is only the beginning. The second step, equally important for astronomers, is to observe with ground-based telescopes. Typically, confirming the planetary nature of detected candidates is crucial, while also helping to refine measurements of their size and orbital characteristics. This next task is particularly important, especially when studying cold stars like LP8909. The host star of the two newly discovered super-Earths emits most of its light in the form of infrared radiation, while the TESS telescope has limited sensitivity in this wavelength range. This weakness of TESS is also a commonality shared by the telescopes in the Speculos project. Located in Chile and on the island of Tenerife, an island just off the western coast of Morocco. These telescopes are equipped with cameras that are extremely sensitive to near-infrared light. In the light of exciting scientific advancements, we are moving toward a new future. Michael Gillen, an astronomer at the University of Liège and the principal investigator for the SPECULUS project, stated, "The goal of SPECULUS is to search for planets capable of sustaining life. orbiting some of the smallest and coolest stars in the Sun's neighborhood. This strategy is driven by the fact that such planets are particularly well suited for detailed studies of their atmospheres and search for chemical signatures that could prove the existence of life using large-scale observatories, such as NASA's James Webb Space Telescope. Michael Gillen compared the discovery of two super-Earths, LP8909b and LP8909c, orbiting the cold star LP8909 to the quest for exoplanets in the CHAPBIT-1 system. Of the 7 known exoplanets orbiting the CHAPBIT-1 star system, 3 are located within the habitable zone. This has made the CHAPBIT-1 system a central target for astronomers to conduct in-depth research. And in fact, one of these newly discovered worlds lies right within the habitable zone of its host star LP890-9, making further study of this star system incredibly compelling. This is precisely the point that has captured the scientific community's special attention. Professor Amory Chayat, an astrophysicist at the University of Birmingham in the UK and head of the Speckles Working Group, stated, "This allows us to observe more deeply, to determine whether the planet LP890-9c has an atmosphere. We will continue to investigate the nature of this planet and assess its potential to become a habitable environment for humans. Scientists will study the factors that contribute to the creation of life, such as a planet's size and its distance from its host star, along with the size and temperature of the star itself." Professor Amory Chayat explained it as follows. The habitable zone is a concept referring to planets with physical and atmospheric conditions similar to Earth's. This surface temperature would allow water to exist in liquid form for billions of years. It is crucial to detect as many temperate planets as possible, in order to study the diversity of exoplanet climates and thereby identify the most suitable locations for measuring the frequency of life in the universe. Next, scientists hope to study the atmosphere of the exoplanet Kelt 9b, after the James Webb Telescope recently detected carbon dioxide molecules in the atmosphere of an exoplanet. And with these inventions, humanity's hopes and aspirations for extraterrestrial life will no longer be a distant dream, but gradually become a tangible possibility in the future. Scientists will continue to strive to explore these planets and other solar systems more deeply, thereby laying the groundwork for the search for extraterrestrial life and our place in the vast universe. Thank you all for watching this video.